So, hi everyone, how is everyone doing? It's Dora the Explorer, you have to respond to me. How is everyone doing? Great, okay, awesome, I'm so glad to hear that you're doing great. So, I'm so sorry, Miss Mana. Okay, so anyway, today we're gonna be going over some quadrant problems. That's why I have a graph drawn out here. We're gonna go over how to use the calculator properly, and then we're also gonna go over reciprocals. Again, these are some things that I felt like after the assessment, we just needed to look at again. So, have a lot kind of scribbled on the board, but it's okay. The main thing I want you to focus on right now is this graph. Hopefully, a graph makes sense to you. It should at this point, right? We have our x-axis right here going horizontally, we have our y-axis here going vertically. Now, the quadrants. Why do the quadrants matter? We got quadrant 2, quadrant 3, and quadrant 4 down here. Notice that they go counterclockwise. This is important. Why? Because when we look at angles in a circle, right? Like I showed you yesterday or the day before, whatever, when we were doing coterminal angle, counterclockwise is positive. Remember that, okay. And the other thing I wanted you to remember is that in this first quadrant, our x value, because we're to the right on the graph, is positive. Our y value is also positive because up here, we're above. So we're on the positive and the y-axis. Over here, we're to the left of the graph. So that means our x values are negative. But up here, our y value is positive because we're above this line. And down here, our y value is negative because we're below the line. And then opposite over here, right? We're below the line, right? So our y value is negative, but we're to the right of the graph again. So our x values are positive. I said that very quickly, and I apologize. So again, just to refresh, x is positive on this side, x is negative on this side, y is positive up, and y is negative going down. And so that's why we have our corresponding positives and negatives as our points on our graph, our coordinate points, our xy coordinate points. Remember, it's always written as xy, xy. X goes first, our y comes second. Okay? So, with that out of the way, I'm going to do just quickly a practice problem. So I'm going to erase some of this and I'm going to pause. Okay, so let's say we're given this point right here, 6, 8 on a graph. So 6 is our x, 8 is our y. Right? So that means we're going to be right here. 1, 2, 3, 4, 5, 6. And 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're right there on the graph. Now, let's say they tell us that the terminal side of our angle goes through that point. Well, what does that mean? Why are we suddenly having angles on this graph? I thought we just had x and y. Well, the thing is that just like yesterday when we went over coterminal angles, we know that we can actually place a circle of 360 degrees on a graph, right? So yesterday I told you that this right here is 0 degrees, right? I told you that this up here is 90, that this right here is 180, and this down here is 270. And then coming back around, this is 360 again. So you go in a full circle. Again, notice we're going counterclockwise in the positive direction, right? And that's how you found your coterminal angles. Well, now let's imagine that we place that circle, those 360 degrees, on top of this xy axis. And now we have a point on a graph, and we want to find the angle that goes through, or the angle that is formed by the terminal side that goes through that point. So what does that look like? Well, if this right here, again, this is always our initial side, right? Our initial side is right here, just like we did yesterday with our coterminal angles. This is our initial side. Well, our terminal side goes through this point, which means if we're forming an angle, right, because an angle is always formed out of two sides, right? This is an acute angle, this is an obtuse angle, right? It's always two sides. Our one side, our other side goes right through this point. And that means this right here is our terminal side. It goes through the point 6, 8, terminal side. Now we've formed, right, based on these lines, right? And based on the angle that we formed right here, this is our theta, which is just our variable for our angle, our theta, right? Because we're already using x and y. If we're already using x and y, we don't want to call our angle x or y. We don't know it yet, so we just call it theta. That's the variable that we use. I'll write it. Theta, theta, okay? It's just a circle with a line through it. We have our theta here. We have this side, we have this side, we have our x, and we have our y. And do you notice what shape is forming in here? A triangle. We have a right triangle formed. Okay? Here's our right triangle formed. Right here. And this right here is our hypotenuse. Okay? So now, we're given our side lengths, and we can find our hypotenuse if we want to. Where are our side lengths, you might ask? Well, it's right here, right? This is 1, 2, 3, 4, 5, 6. We know it's 6, we were given that as our point. So this side is 6 units long. Now what about this side? Well, that's going to be 8. We were given that, right? 1, 2, 3, 4, 5, 6, 7, 8. Right here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Right? This side right here is 8 units tall. And now how do we find our hypotenuse right here? The Pythagorean theorem. Right? So let's go through the Pythagorean theorem again, and then we'll find out the length of this side together, okay? So where do I even have space on the board for this? I'll erase that. Oh, my paper. Okay, we'll do it right here. So we have 6, right? So we've got 6 squared plus 8 squared equals our, I'll call it C, right? Because then a squared plus b squared is c squared. We'll call it c squared. Well, 6 squared is just 6 times 6, right? Because squares work like this, right? You got 1, 2, that's where the 2 comes from. 6 times 6 is 36. And 8 times 8 is 64. Okay, you add those together, you get 100, and that is equal to c squared. So that means we have the square, we gotta take the square root. So we get c equals 10. Okay, so that means that this right here, from our origin, right, because this is how we form angles, right, in a circle, from right here to our point right here that our terminal side goes through, this is 10. So now I could tell you, you have like all the sides of the triangle right here. I'm going to erase all the ugliness around so that way we're just looking at our triangle. So now I can ask you, just based on this point, that's all that we had from the beginning, now I can tell you the secant, the sine, the cosine, the tangent, the cotangent, the cosecant. I can tell you any of those because I have all of the signs right here. I have all of the signs. So let's say I want.
Okay.
Okay. So let's say we have sine of theta. We don't know theta yet, right? That's going to be opposite over hypotenuse, right? So if this is our angle, our opposite is right here. It's our 8 over our hypotenuse 10. Okay, and there it is. Now I can ask you cosecant. Well, we know cosecant is just the opposite or the flipped of sine, right? So instead of opposite over hypotenuse, it's hypotenuse over opposite. Okay, and you could do that for any of the 6 functions now because you have all the sides. All you needed was a point on a graph, and now you have your cosine, sine, tangent, secant, cosecant, and cotangent for that terminal side, for that angle, for that theta, okay? Now, on the test it was a little different, right? So I'm gonna show you that really quick, because sometimes you're not gonna be given the point. Sometimes you're gonna be given the function and you have to work around it, okay? And I'm gonna also go onto some negative sides. So this quadrant right here, we know that both our x and our y and are positive, which makes it easier, but sometimes they're negative. So I'm going to do an example probably down here in the 3rd quadrant, okay, so we can get an example of what it looks like to have a negative coordinate point. Okay?
Okay.
Okay. Did you pause it or no?
No, did you want me to?
Yeah, could you? All right. So before I move on to another example of how to like work with the quadrants and the points and the functions, I want to go over something that I think wasn't very clear the first time I explained it around, so I really, really want to make sure that this is known now. I'm going to go over the reference angle. All right, so the reference angle, all it is, I'll write this down so that you know. Reference angle is the angle that we reference between, so it's the angle between the x-axis and our terminal side. Yeah, okay.
What does BW mean?
BW, true. This is just an abbreviation for between. Okay. So angle between our x-axis and our terminal side. And our terminal side. So where theta is the angle between our initial side, which is always right here, our initial side. Theta is between our initial side and our terminal side. Our reference angle is between the x-axis and our terminal side. So last time when we did an example up here, this was our terminal side right here. Let's pretend that says terminal nicely. Our reference angle was our terminal angle because the x-axis and the terminal side, as well as the initial side and the terminal side, are the same. We're still referencing this theta right here, this angle right here. But let's say we're over on this quadrant, in the second quadrant. Okay. So let's say we're drawing an angle over here. This right here is theta. This is the side, or the angle, I should say, between our initial and our terminal side. And then we label this terminal side. So this is our terminal angle. But this right here, this, I'm calling it A for now, just so that we don't get confused. This angle right here, that's our reference angle. So when we make our little triangle, our little right triangles like this is the angle we're going to use based off of the origin. It's the angle between the x-axis and the terminal side. Okay? So let's say I give you a point over here, right? Last time I gave you a point up here, let's say I give you a point over here now. Instead of using this entire side, when we draw our points in and when we do like opposite, adjacent, that type of stuff, we're going to use this angle right here as our reference angle, this down here. Now, let's say theta is down here in the third quadrant. So theta is our initial. We open all the way up. We create an angle that starts, or that ends all the way down here, terminates down here. This is our terminal side. Right here. That's our terminal side now. This entire angle going here, that's theta. But this little angle right here between the x-axis and the terminal side, this is our reference angle. Right here. So when we make a little right triangle, right, we're going to make a triangle that looks like this. And now when I ask you what the opposite side of this triangle is, you're going to use this angle right here, and you're going to tell me, oh, the opposite side is right here. It's this side. And notice that that's our y value. And when I ask, oh, well, what's the adjacent side to theta, you're going to use this reference angle, and you're going to tell me, oh, this is the adjacent side. Right here. So notice that there's a relationship between the adjacent side and the x-axis, your x value, and there's a relationship between your opposite side and your y value. And I'll draw that again up here just so that that point is very clear, because I want that point to get through your head, okay? There's a relationship, a direct relationship, between your x and your y values and your opposing and opposite sides. So if we're back up here, right, this is our theta, this is our reference angle, that's our reference angle. If we're drawing our right triangle, if this is our angle, our adjacent side is right here. You see, it's different now. Our adjacent side is still this side, okay? It's still our x. our adjacent side, I'll write this down, your adjacent side is directly connected to your x value, right? If we have a point right here, x, y, your adjacent side is directly connected to your x value. And your opposite side, x value. And your opposite side right here is your y value, right? Your opposite side goes with your y value, okay? So when you're doing SOHCAHTOA, keep in mind that your adjacent side, or your x value, your adjacent side, your A in SOHCAHTOA. All right, so back at it, right? Our adjacent side is going to be connected to our cosine, and our opposing side is going to be connected to our sine. Just keep that in mind. That's a relationship that I want you to get very familiar with, because you're going to need that in the unit circle. That your adjacent side, your x value, and your cosine are all connected. And that your y value, your opposing side, and your sine are all connected. Y, A, adjacent, is your adjacent side, and your cosine, and O, and opposite side, that's your O and your sine, right? So if that's a little complicated, I just want you to keep in mind that cosine, your x value, your adjacent side, those are all connected. Your y value, your sine, your opposing side, your opposite side, those are connected. Those are like a trio, okay? That's all that I need you to know about this. Just keep in mind reference angle, all right? Reference angle. So now we're gonna do a practice problem, and we're gonna use that reference angle, and we're gonna do math. Pause. So, given that our theta is between 270 degrees and 360 degrees, and the tangent of theta is -3/4, let's find out some stuff, okay? So what does this first part of the equation, or not equation, but first part of the given mean? This means that our angle, all right, starting from the initial side right here, right, this is our initial side, starting from here, our angle is gonna go around, and it's gonna be somewhere between 270 and 360. So it's gonna be somewhere here. Somewhere in this region, we're gonna have our terminal side. Somewhere in there, okay? This right here, our terminal side. Now keep in mind that because we're in quadrant 4 down here, our x is positive, our y is negative, right? Because we're to the left, but we're to the bottom, okay? X is positive, y is negative. Now we're given that the tangent of theta is -3/4. Okay. Well, what do we know about tangent, right? Well, we know SOHCAHTOA, right? So tangent is right here. So our tangent is our opposite over our adjacent. Let me write this over here so that you can see a little clearer. Opposite over adjacent, okay? Which means, pretty simply, that our opposite side is 3, and then our adjacent side is 4. So now, this is why the reference angle is important. Well, where's the opposite from here? Where's the adjacent from here? Where's the triangle, right? Well, we know that our reference angle is always between our x-axis and our terminal side. So this is our reference angle right here. And now, we know that if we're looking at this right here, that we can just go like this, and like this, and make a right triangle right here. Right? Does everyone see this right triangle forming here? And now if this is the reference angle, we know that our opposite side is right here. So that's going to be 3. And then our adjacent side is right here. This is the angle, our adjacent side is next to it. This is 4. All right, cool, but where is this negative coming from? Oh, right, we're in the 4th quadrant. Our y value is negative, which makes sense, right? Because we're going down 3. We're going -3. All right, so that means that this point right here on the graph for this stuff that we're given is 4, -3. Awesome. So now we have a triangle that's formed, and we can find our hypotenuse right here from the origin to this terminal side point, right? So I'm going to move this out of the way. I'm going to call this C. And then just a squared plus b squared is c squared. We can find our hypotenuse, right? So squared plus b squared equals c squared. So we have a and b, right? Negative 3 squared plus 4 squared is c squared. We get 9 plus 16. We'll get to that. Is 25 equals c squared. So then we'll take the square root, right? And we get that c equals 5. And hopefully that feels normal now that you see a lot of 3, 4, and 5s, because that's a perfect square. That's what we call a perfect square. When you plug in a, b, and c, 3, 4, and 5 come out as whole numbers, because c doesn't always come out as a whole number, right? Sometimes it comes out as like the square root of 37, and that's like not a nice whole number, but 5 works. So that's why we call it a perfect square. So now I can ask you, based on this information, because we have all of our sides, I can be like, all right, well, what sine, if this is still theta, right? Theta goes all the way around. So this is our theta. Well, what's sine theta, right? Sine theta. We're going to use this reference angle, right? Sine is opposite over hypotenuse, right? So opposite over hypotenuse. So it's negative 3 over 4, or negative 3 over 5. And you could do the same with, let's say, secant, right? So if you remember reciprocals, I will go over reciprocals a little bit later in this video, but hopefully you remember secant goes with cosine. So instead of adjacent over hypotenuse, we do hypotenuse over adjacent. So 5 over 4, okay? I don't want to go too much into that because we'll go over reciprocals again in a little bit. But this is how you're able to form a triangle and find all of the functions based on any given angle, right? Just using the reference angle, using one of the functions, and just knowing which quadrant you're in, okay? So hopefully this problem makes more sense to you now, all right? So I'm calling quadrant problems done. Next, we're gonna go on to using the calculator properly, okay? All right, so I've taken this off of a graph. We're just gonna look at a triangle, and then I'll put it on a graph, and then we'll work from there. But right now, we're just gonna use the calculator to find out our missing side, okay? So we have our right triangle here. We're given that this angle down here is 37 degrees. We're given that our hypotenuse, right, because that's our longest side, our hypotenuse is 11, and we're trying to find this side right here. Well, what do? How do we do that? Because we don't have all the sides, right? So we can't do the Pythagorean theorem. And this is why we use trig, because we can use this angle to find that side. How? This is how. So we need to look at SOHCAHTOA. And we need to ask ourselves, which of these functions, sine, cosine, and tangent, which of these functions, I hate when the lights turn off randomly like that. Ghosty, okay. Which of these 3 functions we can use? Well, we're looking for our opposite side, right? This is our opposite side. This is what we're looking for. And we have our hypotenuse. So we want to look at the function that uses opposite and hypotenuse. Miss Mena made fun of me. She went like this. I was like, yes, you did great. Okay, we want to use the function that utilizes the opposite and the hypotenuse. Which one is that? Well, which one has O and H? Sine, right? Opposite over hypotenuse. So this is all we're going to do. We're just going to do sine of our angle, right? Because for a while we've been just putting in theta, but now we know the angle. We know that it's 37 degrees. Is equal to our opposite side that we don't know yet, right? Divided by our hypotenuse, which we know is 11. And now, it's algebra. We can do this. We can just plug this into the calculator. So, if you want, the first step you can do is just plug in sine 37. Okay, so I'm going to plug that in real quick. Sine 37. I want you to make sure you're using degree mode right now.
Show them.
Okay, I'll show you. Here you go. here's the sine of 37 degrees, okay? You get 0.6018, okay?
It didn't focus.
Let's try again.
I can see sine degree 37, but I can't see the answer.
All right, well, the answer is 0.6018, okay? So here, I'll write that down. 0.6018, okay? Again, just to go back to the point I was trying to make sure your calculator is on degree mode right now. You have not learned radians. Make sure your calculator is not on radian mode. The way you'll know you're on degree mode is your calculator will say DEG. It'll be visible, DEG mode. If it says RAD, right? If it says in any corner or something RED or any tab or something that says RED, you are on radian mode. You do not want to be on radian mode. If there's a button that says radian mode, don't click it. Stay on degree mode, okay? So if you stay on degree mode and you type in sine of 37, you're going to get 0.6018. And that is going to be equal to x over 11. Now what do we do in algebra when we want to get x by itself in this circumstance? We multiply both sides by 11, right? So in other words, 11 times 0.6018 is equal to x. And all you have to do now is just solve for this. So let's put that in the calculator. 0.6018 times 11 is going to get you about 6.62. So x equals 6.62. And that is how you find your missing side. So this right here is 6.62.
That's it.
That's it. And this is going to help you a lot when you're doing the word problems. And we're going to go over word problems, I think, next week. But let's just get some practice with this. All right, I'm going to definitely give you some practice problems on this alone. Okay, now I'm going to take this, I'm going to put it on a graph, and we're going to look at it that way. So pause. All right, so this time around, all I did was just take a triangle and put it on the graph, just so that we can get familiar with the feeling of having a triangle on a graph, right? And this time, we're given that the angle is 54 degrees, okay? We're given that our hypotenuse is 8, and we're trying to find this side right here. I've called it A. And now why haven't I called it X? Well, because we already have an x-axis labeled, and we already have a y-axis labeled, so I don't want to use those variables again. We'll just call it A, okay?
Okay.
Cool, thank you. So, what's this side now, right? We have our hypotenuse. If we're looking at this angle, well, this is our adjacent side, right? So, and so katawa, we have to ask ourselves again, which function can we use? Well, we have hypotenuse, we have adjacent, we have hypotenuse, we have adjacent, so we can use this one, right? We can use cosine. So we'll do that. We'll do cosine of our 54 degrees that we're given is equal to our adjacent, which we're calling A, I conveniently labeled A, and over our hypotenuse. All right? And again, we can just plug that into the calculator, so let's do that. So cosine of 54 degrees. I want you to try this out on your own. But I'm going to tell you, I'm not going to show you because it didn't focus last time, so there's no point. 0.588.
Perfect.
0.588 equals A over 8. Again, just like last time, we'll multiply both sides by 8. So we get 8 times, times 0.588 is A. So let's just put that in now. 4.7.
That's a nice number.
It's not totally. It's,
Oh, got it. You rounded.
I rounded. 4.7. So that means that this right here is going to be 4.7 degree, or not degrees, units, right? This right here, 4.7. Cool. I hope now we know how to actually use a calculator when we're trying to find sides and stuff in a triangle. I'm hoping we're feeling better about that. I will practice problems, and I will do tangent. So keep in mind tangent. And sometimes also keep in mind where your variable is in your fraction, right? Because if your variable is down here, you don't multiply by 8 like we did before, right? You have to multiply by a and then divide by the cosine. So just be careful. That part didn't make sense. I'm sorry, I didn't explain, like I didn't show it visually very well, but just be careful of your algebra, okay? Just be careful how you're doing your actual equation. And that's all I'm gonna say about that, because I wanna get onto reciprocals and how to do those in the calculator as well. So we know that we have 3 regular trigonometric functions. If that word doesn't feel familiar, it should be. Why?
We're in trig.
Because we're in trig, but also these are 3 of our regular common trig functions that we've been using. We use them a lot, right? Sine, cosine, tangent. So let me write those. We got sine, which the full way to spell it out, by the way, is sine. That's why I pronounce it like that. That's why I don't say sin when I read it this, because it's sine. That's the function, right? We got cosine, which is actually cosine. And we've got tangent, which is like, this is how you spell it out completely, tangent. We know sine.
Who came up with these?
Wait, what?
Who came up with these?
Yeah, I know, they actually mean things. Not gonna require you to know that, but they mean things. Anyway, sine, we know in SOHCAHTOA is opposite over hypotenuse, right? Opposite over hypotenuse. Here, I'll write those out a little bit more. Opposite hypotenuse. Okay. We know cosine, right here, in ka, is adjacent over hypotenuse. Adjacent over hypotenuse. Okay. And our tangent, our TOA, is opposite over adjacent. Okay. Now, our reciprocal functions, all they are just flipped. We have a ratio here, right, of one side to another side. The reciprocal is just flipping those sides. That's all reciprocal means, okay? So when we're looking at sine, here, I'm gonna write this out, kind of like a little chart, okay? So when we're looking at sine, the reciprocal function is cosecant, okay? That's the CSC that we've been looking at. It's like this, cosecant, okay? And all that is the flip of sine. One way to write that is 1 divided by sine. Okay? You need to keep that in mind, because when we're using the calculator, if you don't know how to do it any other way, this is going to help you calculate your reciprocal functions, okay?
Okay.
So if sine is opposite over hypotenuse, cosecant is just hypotenuse over opposite. It's just h over o. All it is, o over h over o. It's just flipped. Yeah? Now same thing goes with cosine and secant. That's this one that you all have been singing. Secant, it's spelled like that. Secant. We can write that as 1 over cosine. You see? Sine, sine, cosine, cosine. 1 over cosine. So instead of cosine being adjacent over hypotenuse, now we get hypotenuse over adjacent. It's just flipped. And now the same thing goes with the last one. This one hopefully is a little bit more intuitive because it actually sounds similar, right? Is COT, which stands for cotangent. All right? So where tangent was TOA, opposite over adjacent, we'll get 1 over tangent, and we'll get adjacent over opposite. That's a really ugly O, but you get the point, right? So that's what the reciprocal functions are, okay? So
Okay.
now let's just try to do some calculations of this on the calculator, okay? Okay, so let's say we're asked to find cosecant of 134. All we have to do is just ask ourselves, one, what's the reciprocal function? Which one pairs up with cosecant? Hopefully, you
Sine.
remember from the chart. Did you tell them?
Sine?
Mm-hmm, sine. So if cosecant goes with sine, then that means that we can use sine to calculate this on a calculator, okay? Actually, in fact, if you remember, in fact, I embarrassed myself. All right. Anyway, we know that cosecant, we just wrote it out, that cosecant is actually 1 over sine. I wrote it out. It was there. Hopefully you wrote that in your notes too. 1 over sine, right? So that means the cosecant of 134 degrees is just 1 divided by the sine of 134 degrees. So if it's easier for you to just type this into the calculator and then do 1 divided by that, do it that way. So let's calculate sine of 134. So just plug that into the calculator, sine of 134. You're going to get 0.719. Okay? So 1 divided by 0.719. 3. Let's add it. Why not? Okay.
Why not?
Yeah, why not? So another way to write this out, in case it makes it easier for you to visualize, 1 divided by 0.7193. This is how you can type that into your calculator. Okay? When you do that, 1 divided by 0.7193, you're going to get 1.3902. That's it. That is your answer for cosecant of 134 degrees. Simple. All right, so let's try an example with secant. So let's do secant of, give me like a bigger degree, Miss Mena.
Like 72.
Okay, sure. That's like a small degree, but it's fine.
Oh.
It's okay. It's fine.
Oh, you meant like 180.
It's fine. I wrote it down now, so I'm not going back.
Whatever.
All right. So secant of 72 degrees. All right, secant goes with cosine. So we know that secant is 1 over cosine, right? So then secant of 72 is just 1 divided by the cosine of 72. So let's find cosine of 72. So 1 divided by 0.390. All right. So let's plug that in. 1 divided by 0.39. Okay. And we get 2.5641. Okay.
Amazing.
Amazing. That's all there is to that. So when you saw those questions on the test, that's all I was asking you to do. Hi. This is me in post-production. I explained something wrong, so I had to cut it out of the video. I'm about to wrap things up, but just ignore what's behind me on the board. That's it for me today. This was a lot more intensive, but I did want to go like a little slower and just really kind of wrap things up a little bit better. We are going to have to do a review on the unit circle and word problems, but for now, I'm glad that we got these 3 things out of the way. Checklist done. Have a good day. Do the assignment. Turn it in for me. I hope you have a lovely day.